The last component in our concept or our discussions about doing security is going to be controlling what traffic is going to be dealt with and handled. So when we start looking at this, it really is going to be using access lists to implement some level or some type of traffic filtering. Now, when it comes to traffic filtering, we've seen an example of how I implemented it in one of our labs, and we've also discussed it. All I'm going to do is I'm going to use either standard access list or extended access list or named access lists to filter based on source, and the idea of a standard access list based on source, destination, or port number using an extended access list. And we're going to have to recognize that there's going to be certain rules with regard to how we can most efficiently deploy these particular parameters. So in this scenario, how would I restrict internet access for PC2? Now, in the confines of PC2, I want to make certain that I restrict access for it up to the internet connection. So what's involved in that process? Well, first what we need to do is we need to take a look at what's happening. We can configure an access list. Now, we have an ACE, an access control engine, that it just so happens to be the parser that runs the lists that we implement. Now, when we look at this, let's assume that this is a router itself. This entire box is a router. So we see E0, S0, S1. So we have two serial interfaces and an Ethernet interface. Now, if we have inbound packets coming on this interface, what we need to do is we need to first of all look up our routing table entry. In the confines of our routing table entry, if we have a prefix, it's going to move forward and it's going to pick an interface which we're going to switch it to. If there's nothing, what's going to end up happening is it's going to get dropped and put in the discard bucket. So assuming that we have a route in our routing table, then what we're going to do is we're going to check any access lists that we may have. Is there an access list on this interface inbound? Now, if there's an access list on this interface inbound, yes, and it's going to be configured. Notice that we have different options. If there's no access list, it's immediately going to forward the packet out the interface in question. If there is an access list, what it's going to do is we're going to test the access list section. We're going to go through and parse it in order. If anything matches, what's going to end up happening is we're going to determine whether or not it's a permit or a deny. If it's a permit, we're going to forward the traffic. If it's a deny, the information is going to get sent to the bit bucket. So as you can see, what we're doing is on a case-by-case basis, based on inbound or outbound configuration of access list, we're making a determination either whether or not the traffic is going to be forwarded or the traffic is going to be black-holed or dropped. So again, pretty straightforward with regard to how access lists operate in the confines of CCNA. Now, how do we apply them? Well, like I said, we apply them to interfaces, and in the option or the capability of applying them, we can do them in outbound or inbound fashion. So keeping in mind that that one single command, IP access-group, the access list number, in this case we see 1 and 2, which means we're using standard access lists, either inbound or outbound on a given interface. So simple enough, and we've already seen that deployed in our examples. So let's return to this scenario that we have here, where we want to say, I want to deny access for a specific host. In other words, I do not want IP address 10.1.101 PC2 to have access to the internet. I want all the other devices to have access, but I want to block any information sourced from 10.1.1.101. Well, the moment I say sourced, we know I'm talking about a standard access list. So in the confines here, all I'm going to do is I'm going to create an entry that's going to say access-list, the number, and I'm going to say deny traffic for that particular host, 10.1.1.101. Now, because of the implicit deny at the bottom of the access list, I need to countermand that, which means I want everyone else to have access to the internet. So what I'm going to do is I'm going to come in here and I'm going to say access list 1 permit, and then I'm going to allow my entire network. My entire network here is 10.1.1.0/24. As we can see here, 10.1.1.0, or the inverse mask is 0.0.0.255, which translates to 24. And then what we do is we go to the individual interface in question on the device. And in this case, what I'm going to do is I'm going to do that on the outbound interface on the router going towards the internet, and I'm going to apply this access list in the outbound direction. And doing so, what we're going is we're filtering that traffic as it tries to leave our infrastructure. Now when we start taking a look at this, why do we have another requirement? We talked about standard access lists, but when or why would we use extended access lists? We talked about standard access lists. When or why would I use extended access lists? When I look at using an extended access list, I'm going to be matching on some particular elements. I may choose to match on the source IP. I may choose to match on the destination IP. I may choose to match on a port. And a port means a service. So in this scenario, I want to make certain that PC2, I want to prevent it from accessing only a specific server on the internet. So in other words, I don't want PC2 to be able to access this specific IP address here, 209.165.202.197. I want to, and I can't allow all other users to access only to come in and do access to just web services. So they're going to be, how can I allow other devices, like for instance PC1, to have access while restricting PC2? Well, let's take a look at that. What we find ourselves doing is we're looking at a scenario where we're going to use an extended access list. Extended access list means we're going to cite the source or we're going to cite the destination. And what we need to do is look at our options. So inside the context of an extended access list, understand that we can filter on destination addresses, source address, protocol, and port number, all found available inside of the IP headers of our packets. And then once we do this, based on our configuration, we're going to either deny or permit traffic to be able to exit or enter our interfaces. So to make this real, what we're going to end up having to do is we're going to have to create the access list and we're going to have to apply it on the specific prefix. Now I said that we were going to restrict access from the address of 10.1.1.101, and I wanted to make certain that it did not able or had the capability of hitting 209.165.202.197. But I wanted every other device in my infrastructure, so anything that's not 10.1.1.101, to be able to access anything as long as it's trying to reach port 80. Port 80 means HTTP, so web browsing. So that's exactly what we have here. Notice I have my source address, I have my destination address, I'm denying that traffic. Any other traffic that doesn't match this is going to be permitted so long as it's TCP traffic sourced from our network, 10.1.1.0, and it's destined to any address that has with a port of 80. So in other words, what I'm doing is I'm permitting TCP port 80, which implies HTTP access. And also bear in mind, all other traffic after this is going to be denied because of the implicit deny at the end of the list. We go to the interface in question, and we use the IP access group 110 in command, and in this scenario what we're going to be doing is we're actually doing this configuration as it arrives on the router, not as it leaves, just to illustrate the point that we can do it in different ways and different fashions. Now again, if I want to configure a named access list, I'm just going to specify the name. It's going to begin with IP this time. It's not going to be access-list. It's going to be IP space access-list, and then I'm going to give it the variable of standard or extended, and then I'm going to assign the name. In this scenario, what I do is I have the capability of saying or permitting traffic. So here I'm permitting traffic. Here I have the permit for everything else. So on this scenario, notice that I've created an access list just using a name. It is an extended access list, and again, I'm going to deploy it on the interface, inbound or outbound, based on my individual requirements and what it is I'm actually trying to do. So when I configure a named access list, I want to be able to see that access list. We've already talked about a lot of these details. I can actually view it, I can see what's going on, I can create it, I can even edit it. Even if it's not a named access list, I can still edit it, because I cannot create a named access list using pure numbers, because every possible numeric access list is already reserved as a named, so I can go in and do the editing. Remember, I mentioned the fact that in the day when I was coming up, I didn't have the capability, or we didn't have the capability of being able to edit the numbered access lists until they incorporated this process to allow us to use the syntax of named access lists to actually make things operational and bring things up. Now the other point of this is that we need to understand is that there's going to be some rules. And again, this is going to be one of those components that requires memorization. So when we start looking at using access lists, this is some of the most important information that we're going to look at. So first of all, the type of access list. We have standard and we have extended. It determines specifically what's going to be filtered. The other rule that we want to highlight here is that in the confines of an interface, we can only have one ACL per interface, per protocol, per direction. And what we also want to realize is, like I said earlier, the most specific statement should go to the top of the ACL because in general they're going to be processed from the top down. So more specific at the top, more general at the bottom. Never lose sight of the fact that we have the fact of that implicit deny at the end of an access list. It's going to drop everything that we do not explicitly allow. And then probably the single most important values on this page extend to where we put access lists. Extended ACLs need to be placed close to the source. Standard ACLs need to be placed closer to the destination. This is going to allow us to put efficiencies in place to better allow our access list to restrict traffic without having a scenario where the traffic is going to burden our bandwidth and take away bandwidth and then be denied at the other end. So keeping in mind, we place extended access lists close to the source and we place standard access lists closer to the destination. So again, very important elements that we want to be able to keep track of. And an ACL can be used to filter traffic going through the router or traffic to and from the router. So bearing in mind, using these access lists, we see a great number of benefits that come out of employing an access list. An access list allows us to be able to set up many scenarios, and it gives us the capability of being able to deploy filtration. If I want to look at my access lists, all I simply have to do is use the show access list command. The show access list command is going to give me a list of each of my access lists. It's going to show me my sequence numbers, and it's going to give me all of the information associated with all of my lists, whether it's numbered or whether it's going to be something like an access list that has names. Now, when we look at this, what ends up happening is lastly, when we want to monitor these access lists, we've already seen the fact that when I do and have a match, what's going to happen is I have the option of determining whether or not an interface is actually applied or an access list is applied to an interface. The show IP interface, specify the interface, is going to give me any access lists that are applied outgoing or inbound. Notice here we have no outgoing access list, but here we have one inbound access list that is named, and it's going to be called web only. Now, the idea is again, we use these access lists to filter information. Pay attention to where we place our prefixes. When we have the idea of a standard access list, do not lose sight of the fact that it needs to go close to the destination. If we have an extended access list, we want to make certain that it's placed closest to the source. That's going to play into whether or not we're going to be using it in the direction inbound or outbound on any given interface and what interfaces we choose. So this wraps up our conversation about all of the basics and fundamentals assigned to access lists and security. We've talked about hardening, we've talked about how to restrict traffic, and we've also talked about how to protect ourselves from having ports and services running in our environment. So that wraps up security. I'll see you guys in the next module. Bye-bye.